Another technique of factoring is by grouping. When there are four terms, we use a process called factor by grouping. This is the only time that we are going to factor using this technique. Sometimes teachers will teach students how to create four terms, but since you already know how to factor using the trial and error method, this is only used when we are given the setup already for us in four terms. There's really no need to go through this process unless we're given the four terms. So that's the long story short, is when there are four terms, that's when we use this process. Let's start with number one. Now number one is not four terms. Number one only has two terms, but we're going to look at a skill that we have. We have two terms, and we look for the greatest common factor. So our greatest common factor of these two terms is a plus 3. So I'm going to factor out that a plus 3 just like I would with any other common factor to the terms in the expression. Then I'm going to have parentheses, and if I factor out an a plus 3, that's going to leave me x, and then this plus sign, and then I factor out the a plus 3 of this from the second term, and it leaves me a 5. So this factors to be a plus 3 times x plus 5. Factored. Okay, let's look at the next. We've got two terms. Do they have anything in common? They absolutely do. They have x plus y in common. So I'm going to factor out x plus y. And when I factor out the x plus y from both terms, that's going to leave us 4 minus a. So our answer is x plus 4 times 4 minus a. Okay, let's look at number 3. Again, we're factoring, not multiplying out. So we're going to factor what's common. Again, we have two terms. What's common to each term? Well, there's an x plus 6 that's common to each term. And when I factor out the x plus 6 from both terms, what does that leave us in the parentheses? Well, the first term is an x, then I have minus, and then the second term leaves us a 7, so we have x plus 6 times the quantity x minus 7. Okay, you go ahead and try number 4. Okay, if you've tried number 4 in your back, the answer is, and if you didn't try number 4, press pause. The answer is 5x minus 3 times 2x minus 1. Give yourself a pat on the back. Now, how do we get to do this with 4 terms to become what we just saw? We're going to use highlighters again. Highlight the first 2 terms. Highlight the last 2 terms. Okay? Highlight, highlight, highlight. Then we're going to look for the greatest common factor from the first 2 terms. So the greatest common factor would be 3x squared. And that would leave us 5x plus 2. The second grouping is positive 10x plus 4. What's common to both of those terms? A positive 2. When I factor out a positive 2, I get 5x plus 2. Now notice how we went from 4 terms to what we have now, which is 2 terms. Now we look at the 2 terms and we say what's in common between these 2 terms. 5x plus 2 is in common. And if I factor out a 5x plus 2 from both terms, that leaves us 3x squared plus 2. So our factored form is 5x plus 2 times 3x squared plus 2. Okay, let's try that again. We've got 4 terms, so we're going to highlight the first 2 terms, and we're going to highlight the second 2 terms. The first 2 terms have a 5y squared in common, and that's going to leave us y plus 2. The second 2 terms, positive, we always take that sign that's between the yellow and the green. That's the sign we want. So positive, and then what's common to 6y and 12? That would be 2. And that would leave us, actually it would be 3, the greatest common factor. Actually it would be 6. 6 goes into both of those numbers, leaving us y plus 2. And your binomial should be the same. If it's not the same, then you've got to go through what I went through and went, uh-oh, I didn't factor out enough. So that's going to leave us y plus 2 times 5y squared plus 6. Now, I'll know that you're doing it the way I showed you to do it if you write the binomials in the same order that I am. However, if you write them backwards, 5y squared plus 6 times y plus 2, it is the same answer. It is the same answer. Okay, go ahead and try number 7. Press pause, make sure you've got it, and then come back and check your answer. Okay, on number 7, I have 4x squared times 2x plus 7 plus 3 times 2x plus 7. So our answer is 2x plus 7 times the quantity 4x squared plus 3. Okay, number 8 is a little bit different. I'm going to go back to my highlighters. I highlight the first 2 terms. I highlight the second 2 terms. What's common to the first 2 terms? Well, that would be an 8x squared. That's going to leave x minus 6. Now, what's common? I'm going to write this. I'm going to use color here. What's common to the second 2 terms? This negative is very important. We need to factor it out. So it's always going to be a negative when that sign is a negative. So you're always going to take that negative out, and it's going to be negative 5. And if I factor out a negative 5, I'm going to have x minus 6, because negative 5 times negative 6 brings us back to that positive 30. Now what's common to both the blue term and the red term? An x minus 6. And when we factor that out, we have 8x squared minus 5. Okay, let's do one again together, and then number 10, maybe we'll have that as a try. So I highlight the first 2 terms, I highlight the last 2 terms. I'm going to speed it up a little bit. What's common to 12a cubed plus 15a squared? That would be a 3a squared. So 4a plus 5. Then we have that negative, so we're going to factor out a negative. What's common to 28 and 35? A 7. And that's going to leave us 4a plus 5, because I need to multiply back to be a negative 35. What's common to both of these terms? 4a plus 5. And when I factor that out, we get 3a squared minus 7. Okay, if you want to try this next one, you're more than welcome to try it. However, some of them get to be a little interesting, so let's see what we've got here. If you want to try it, you're more than welcome to. I'm going to factor out a v squared, and that'll leave us 4v minus 1. And then from the second one, I'm going to factor out a negative, and that's all we're going to be able to factor out is just that negative. And in parentheses, it's going to leave us 4v minus 1. So what's common to both of these terms? Actually, I'm going to make that a negative 1. There we go. I'm going to factor out a negative 1. So whenever you can't factor something out, they don't have a common numerical value, you're going to show that 1. The reason why it was a negative 1 was because this sign that I've drawn an arrow to is always the sign that determines this. So whenever you're factoring out terms, think of this as the leading coefficient is negative. You have to factor out the negative. So that's going to leave us 4v minus 1 times v squared minus 1. But remember, v squared minus 1 can be further factored. It can. So we have to factor this completely. So that factors to be v plus 1, v minus 1. And then we've got our 4v minus 1 right here. So I'm going to box that answer. And I've got 3 factors for that one. 3 factors for that one. So we always want to look to see if our factors are further factorable. You always want to factor completely. Okay, let's highlight the first 2 terms. Let's highlight the last 2 terms. We'll factor out x squared. That's going to give us 6x plus 1. And then we can factor out the negative, and a 4 goes into 24 and 4. So it's going to leave us 6x plus 1. So we've got 6x plus 1 times the quantity x squared minus 4. But when you know your exponents and you know those squares, you know that 6x plus 1 is good, but it's x squared minus 4 that becomes x plus 2, x minus 2. So this factor was further factorable. So we just have to make sure that we don't have any of those special cases at the end that need to be further factored. I'm going to box it with a highlighter. And let's try number 12. You try number 12. You try it. Press pause. See if you've got it. Still a little tricky because there's 2 variables in there, but I believe in you. I believe in you. I believe. Okay. This is such a good one, I'm going to make it purple. Such a good one, I'm going to make it purple. Okay, so we've got, let's see, let's use a highlighter too. And let's use different color highlighter. Let's use blue and orange. Okay, so out of the blue, what factors? X squared, it's going to leave y minus 3. And then what factors out of the orange? That would be a negative 2, and that would be y minus 3. So we factor out y minus 3, and we're left with x squared minus 2. Now, x squared minus 2, are we going to further factor that over rational numbers? No, because 2 is not a perfect square. 2 is not a perfect square. But for those who are following me right now, just watch. This could be x plus the square root of 2 times x minus the square root of 2. That is neato mosquito. Neato mosquito. True. I don't think I spelled mosquito right. Maybe I did. Mosquito. I know mosquitoes has an ES at the end, but I think mosquito is just with an O at the end. And that's it. That's factor by grouping. So this really honestly is the answer though. When you get to higher level math, what I did in red down here is going to be important. So I just wanted to give you a glimpse. This is a glimpse. Glimpses are good. It shows you what you're going to expect later on. But yeah, this is factoring. So you have completed the factoring unit. If you've gotten this far, you've been exposed to all the factoring that we're going to have for Algebra 1. And we'll be doing more building on factoring in, like I said, every class, every algebra class. So learn to love it.